Fiber. Think of fiber optic internet as the undisputed heavyweight champion of modern networking, while DSL and cable force electrical pulses through heavy copper wires, and satellite beams radio waves through the unpredictable atmosphere. Fiber transmits data using the absolute fastest medium in the universe, light. For your CompTIA A+ exam and your future in cybersecurity, you must be able to contrast fiber with legacy connections. You need to understand its immunity to interference, its massive bandwidth capabilities, and why it is the most physically secure transmission medium we have ever created. The physics of light, glass versus copper. To understand why fiber crushes the competition, you have to look inside the wire. A fiber optic cable contains one or more hair-thin strands of ultrapure glass or plastic. Instead of using electrical voltage to represent binary ones and zeros, equipment at either end uses tiny lasers or LEDs to flash pulses of light. Because fiber uses light instead of electricity, it has a massive physical advantage. It is completely immune to EMI, or electromagnetic interference. If you run a copper cable or DSL line too close to a heavy electrical motor, a microwave, or a high-voltage power line, the magnetic fields will corrupt the data, causing packet loss. Fiber does not care about magnets or electricity. You can wrap a fiber cable directly around a running generator, and the light inside will continue to bounce perfectly from one end to the other. Furthermore, because it does not conduct electricity, it will never carry a lightning strike into your server room to fry your expensive home lab equipment. The architecture, FTTP versus FTTN. When contrasting fiber networks with others, you have to look at how close the glass actually gets to the destination. The gold standard is FTTP, or fiber to the premises. In this setup, the glass cable runs all the way from the provider's central office, down the street, and directly into the building, terminating at the ONT optical network terminal we discussed earlier. This provides maximum speed and reliability. However, laying new glass in the ground through the frozen winter soil of upstate New York is incredibly expensive. Because of this, providers often use a hybrid approach called FTTN, or fiber to the node. In this model, the provider runs the blazing fast fiber to a green metal box at the end of your street. From that box, they use the older existing copper telephone or coaxial cables for the last mile to your house. This is cheaper to install, but it creates a severe bottleneck that limits your overall speed. Symmetrical speeds and ultra-low latency. When comparing performance characteristics, fiber offers two distinct advantages over DSL and cable. First, fiber usually provides symmetrical speeds. On a cable or DSL connection, the provider intentionally makes your download speed much faster than your upload speed, assuming you are just watching movies. But if you are hosting your own local AI models and need to access them remotely, a slow upload speed is a nightmare. Fiber has so much bandwidth that providers routinely offer equal speeds, for example, 1 gigabit down and 1 gigabit up. Second, fiber has incredibly low latency. While satellite internet suffers from massive delays due to the distance to space, fiber data travels through the glass at nearly 2/3 the speed of light. Your ping times to global servers drop to single-digit milliseconds, making real-time applications and secure remote administration flawless. The cybersecurity advantage, physical security. As someone planning a transition into cybersecurity, you must appreciate the physical security of fiber. Copper cables radiate a small electromagnetic field. A skilled hacker with specialized equipment can actually sit next to a copper cable and read the data passing through it without ever touching the wire. This is called a side-channel attack. Fiber does not radiate anything. The light is entirely trapped inside the glass by a reflective layer called the cladding. The only way a hacker can intercept a fiber optic signal is to physically cut the cable and splice a tap into the glass. Doing this instantly drops the light levels, triggering massive alarms at the provider's central office. It is the most secure physical medium in existence. The drawbacks: cost and fragility. The contrast wouldn't be complete without looking at the negatives. Fiber's biggest enemy is physical damage. You can bend a copper Ethernet cable in half, tie it in a knot, and it will probably still work. If you try that with a fiber cable, the glass inside will snap. Even a sharp bend, known as a microbend, can cause the light to leak out of the core, killing the connection. Furthermore, when a copper cable breaks, almost anyone can strip the wires and twist them back together or punch them into a new jack. When a fiber cable breaks, you need a specialized technician with a $10,000 machine called a fusion splicer to carefully melt the microscopic glass strands back together. By mastering the incredible bandwidth, the symmetrical performance, and the strict physical requirements of fiber, you will be prepared to manage the high-speed backbone that connects the modern enterprise.